Hello tech fellows. Welcome back to the Dawn Technology. In today's video, we're going to explore the HTTP status codes every DevOps engineer should know. Whether you're a beginner or an experienced DevOps professional, understanding these status codes is essential for troubleshooting applications, APIs, and web servers. Let's get started.
If you're a backend developer, a system administrator, or really anyone tasked with keeping modern infrastructure up and running, you are absolutely in the right place. Today, we're taking what is usually treated as a pretty dry list of HTTP status codes, and we're going to transform them into an actionable, highly effective incident response toolkit. So let's just dive right in and unlock the secrets that are hiding in your logs. Okay, picture this. It's 2 a.m. Your pager goes off, your heart rate instantly spikes, and all you see glowing on your screen is a 3-digit number. But here's the thing. That number isn't just a random error. Every single response code tells a story. In those chaotic, critical early moments of a production outage, you're essentially a digital detective. And that 3-digit code, well, that's your very first and honestly most critical clue in solving the mystery of what just broke. And this really gets to the core of what's at stake here. Mastering these foundations, it isn't just about memorizing textbook definitions. It's about how you troubleshoot production systems faster. Truly understanding these codes is how you debug complex reverse proxies, figure out why an API is failing, and, surprisingly enough, even how you harden your application's security. At the end of the day, internalizing these codes is the absolute fastest way to drastically reduce your incident response time.
So here's our game plan for today's explainer. Number 1, successes and redirects. Number 2, client errors and security. Number 3, server failures and edge errors. And finally, number 4, the troubleshooting cheat sheet.
All right, let's kick things off with Section 1, Successes and Redirects. So, the 200 series of codes, this is your green light. When you see a 2XX, it literally means the request was received, understood, and accepted. Simply put, the server did exactly what the client asked it to do. This is a super vital piece of baseline information because it tells you unequivocally that the request itself was successful and, crucially, needs no retry whatsoever. Let's look at how a few of these actually map out to backend events in production. A standard 200 OK, right? That's what you want for a routine API request. But notice the nuance here. A 201 created is highly specific. It tells you a resource, like a brand new user via a database insert, was actually successfully generated. And then there's the 206 partial content. That's the unsung hero that makes resuming large file downloads possible. So it's not just a generic success, it tells you exactly how it succeeded.
Next up, we have the 3XX codes. You can think of a 3XX as a detour sign. It means the client has to take some further action to actually complete the request. The server is essentially saying to the client, hey, I hear you, but you aren't at your final destination yet. You need to go over there instead.
For a really practical, modern application of this detour, just look at how a 301 permanent redirect actually secures traffic. It effortlessly catches an unencrypted HTTP request and forcibly upgrades it, pointing the client permanently over to the encrypted HTTPS connection. It's literally just a simple status code doing some serious heavy lifting for your infrastructure's security posture. Moving right along to Section 2, Client Errors and Security. Okay, the absolute crucial point to remember here is this. When you see a 4XX error, the request contains bad syntax or just cannot be fulfilled. Almost always, a 4XX indicates a client-side issue. Your server is sitting there perfectly fine, but the client is either asking for something that doesn't exist, or they are basically walking up and knocking on the front door without holding the right key. Let's rapidly break down a few of these common client missteps. 401 and 403, that means invalid or missing credentials. Like we said, they lack the key. A 404 means they walked up to the completely wrong door, maybe made a typo in the endpoint. A 422 happens when the data they handed you outright fails your schema validation. And a 429, that means they are knocking entirely too fast and have blown right past the request quota. And this actually leads us right into an active defense mechanism. As the engineering handbook points out, good security isn't only firewalls. Correct HTTP responses are actually a vital part of your defense. Using that 429 to rate limit aggressive scraping, or leveraging something like Nginx's custom 444 code to instantly drop a malicious connection without returning a single byte of a response, these are powerful, active weapons in your security arsenal. Before we move to the next tier, we have to make a really critical conceptual leap. When you're in the trenches troubleshooting, remember this exact divide. A 4X means the client messed up. You might need to help them fix their payload, sure. But a 5x? That means the client did everything perfectly right and our server dropped the ball. When you see a 5x, the problem is inside the house, and you can no longer blame the front-end team.
Which brings us to Section 3, server failures and edge errors.
The definition for the 500 family is pretty stark. The server failed to fulfill a valid request. The client asked for something legitimate, they had the right permissions, the payload was absolutely perfect, and our infrastructure just failed to process it. For most of us, this is where the real panic usually sets in.
I really want to pause on this stark reality for a second. Most major production incidents begin right here. If you are a back-end developer, an SRE, or a DevOps engineer, your ability to rapidly diagnose and resolve issues hinges almost entirely on your mastery of these 5x codes. Let's rattle off the major suspects you really need to have memorized. A 500 is a generic internal error. Basically, something crashed in your code and it's probably going to ruin your evening. A 502 bad gateway means your proxy couldn't get a valid response from the backend. A 503 means the service is completely unavailable. Maybe it's overloaded or down for maintenance. And a 504 gateway timeout? That means the backend service took entirely too long to respond and the proxy gave up. Now, in modern infrastructure, we're almost always adding edge networks into the mix. If you follow the request path from, say, Cloudflare to your reverse proxy down to your application, Cloudflare actually uses specific custom codes from 520 to 526 to tell you exactly where the connection broke. A 521 tells you the web server is down completely. A 525 tells you the SSL handshake failed specifically between Cloudflare and your server. These codes provide absolutely vital geographic clues along your network path.
All right, let's tie it all together in Section 4, the troubleshooting cheat sheet.
When everything is burning down around you, you need a simple, reliable system. And it's really just a two-step detective method. Step 1. Look at the first digit. Is it a 4 or a 5? Boom! You instantly isolate the fault to either the client or the server. Step 2. Use a specific checklist based on the exact code to narrow down the suspects within that system. So here is your actionable cheat sheet for that step 2. If you see a 502 bad gateway, don't just sit there guessing. Immediately go check your Docker containers, your upstream services, or your reverse proxy config. If you see a 504 gateway timeout, well, that points you straight toward checking database latency, API timeouts, or maybe a massive, long-running query. This framework cuts right through the noise and gives you a direct path to the root cause.
And this right here is your ultimate takeaway tool, the reference summary matrix. 2xx for success, 3xx for redirect, 4xx for a client issue, and 5xx for a server issue. It lays out all the most common critical codes in one clear view. Ultimately, internalizing these responses is absolutely one of the fastest ways to become a vastly better, more effective DevOps engineer.
Well, we have covered a lot of ground today, transforming these numbers from just frustrating, opaque errors into a strategic map for your incident response. So I'm going to leave you with this provocative thought. Next time your pager goes off at 2 a.m., what story will your response code tell you? Are you ready to read the clues? Thank you for exploring this with us today. Keep that cheat sheet handy and happy troubleshooting.